All right, we've talked a lot about roots, square roots, cube roots, fourth roots, etc. I'm sure you've all been dying to graph them, so that's what this section's about. First of all, how do I graph square root and cube root functions? We're going to be thinking about using transformations. We did this way back in the chapter where we did like absolute value, and we talked about some of the transformations that are happening here. It's the same transformations. Also, how can I write the domain and range? So let's first of all graph the parent function for y equals square root of x. Let's graph some x's and y's. Now, let's think about some nice x's that I can plug in. First of all, 0, very nice x that I can plug in. Square root of 0 is 0. 1, a nice x. Square root of 1 is 1. Probably the next nice one would be 4, right? And then I could also do 9. Okay, but remember, I can't go into negatives, right? Like if I was going to try to take the square root of -4, this would happen to be 2i. It's an imaginary number, and we don't want imaginary numbers right now because I don't know how to graph imaginary numbers on the real number line, which means we should not glow below 0. So let's plot the points that I do have. It just stops at 0, 0, and then it goes on from there, over 4 up 2, over 9 up 3. Now, you can't just write an arrow. I see a lot of people do this. They do this, and then they connect the dots this way. It's not right, because remember, it can't go negative. It doesn't go down here. I can't plug in negative x's. It doesn't make sense. So you must literally stop at 0. There's no ending. This is the stop. Stop. I'll draw a big stop sign there. Do not go any further. Stop. I can't plug in negatives. Also, that may be the best octagon I ever drew. Check plus for Mr. Gregory. All right, now that we know the parent function, let's graph with some transformations. Now, just real quick. Oh, I should have done this. Domain and range. Okay, so the domain. Remember, the domain means all of the x's I can plug in. Well, I can only go 0 and up. So the domain, x has to be greater than or equal to 0. This is the same as saying non-negatives, but since we're doing it in a graph, I want to be a little more analytical probably. And later on when we do transformations, things will get a little trickier. Also the range, notice that the lowest that y ever goes is also 0. And y does go up from there, right? It's going to 1, and then 2, and then 3. But the lowest that y ever goes is 0. And it can't go lower than that because I can't plug in negative x's. So the range also is y greater than or equal to 0. Notice how this 0 and this 0 are sort of related to the stopping point, which happens to be 0, 0. We'll use that fact later on. All right, next. I need to graph this graph. Now, let's graph the parent function, 0, 0, 1, 1, 4, 2, 9, 3. Because remember, if we know how the transformations work, then we can know how to graph this new function without trying to plug in a bunch of decimal points. You can use your calculator to check your work. However, knowing the transformations is what we're going to do. If you remember, we started by graphing the stretch. This is a stretch of 1/2. The thing that's multiplying is a stretch. Also, since it's a negative, I have a vertical reflection. So vertical reflection due to the negative, also a stretch by 1/2, which means every single one of these points, I need to stretch by 1/2 and I need to reflect. So 0, 0, stretch by 1/2, I'm stretching the y's by 1/2. 1/2 times 0 is 0, and negative, still 0. This point has a y of 1. A stretch by 1/2 would put it here at 1/2, but due to the negative 1, I'm going to flip that to negative 1/2. This point of up 2, that times 1/2 is 1, but with the reflection, negative 1. This point at 3, half of that is 1.5, but with the reflection, negative 1.5. So here is my stretched and reflected function. However, I'm not done. This is not my final answer. Don't forget that we need then to do some translations. So as I shift my pointer, remember that this is a translation right 3. Remember, this lies to you. This is a translation up 4. So every single point of my stretched function, I need to move in this way. So this point, I'm going right 1, 2, 3, up 1, 2, 3, 4. Here it is. This point, over 1, 2, 3, up 1, 2, 3, 4. Here it is. This point, over 1, 2, 3, up 1, 2, 3, 4. Here it is. This point, over 1, 2, 3, up 1, 2, 3, 4. It's off the graph, but it'll be right about here. Here is my final graph. This blue line is the final. Now remember, this point over here, don't just draw an arrow. It's not an arrow. It is a full stop because we're not allowed to have negatives under the square root. If you try to plug in, for example, an x of 1, so here's where an x of 1 would be. Let's try to plug it into the function. Negative 1/2 square root 1 minus 3 plus 4. Hey, what's 1 minus 3? Negative 2. Hey, can you take the square root of negative 2? No, fool, you can't. So there is nothing over there. It is a full stop. Therefore, what is my domain? The lowest x that I can possibly have, we can see this from the graph, the lowest x is 3, and then it goes up from there. So look at this point. This is the point 3, 4. The lowest x can be is 3, and then it goes right from there. So x greater than 3. The range, the highest that y can be is 4. Does it go up from there? No, actually it goes down from there. So the highest y can be is 4, and then due to the reflection, y is going down from there. And we can see this from the graph. It is going down. So y is less than or equal to 4. All right, easy. Let's keep moving along. Now, we're going to graph the cube root function. Remember that cube roots, I can plug in negatives. So this makes my life a lot easier. I don't have to worry about any of these weird stops. Let's plug in the cube root of 0 is 0. The cube root of 1, what number times itself 3 times is 1? Well, 1. And the next nice cube I know is 8. The cube root of 8 is 2. But don't forget that I can also do their negatives. The cube root of negative 1 is negative 1, because negative 1 times negative 1 times negative 1 really does give me negative 1. These two negatives cancel. I'm left with this one. Likewise, the cube root of negative 8 is going to be negative 2. So, x negative 8, y negative 2. Let's plot these points. Now, I see a lot of people in their classwork, not your class, just from previous classes, doing this really badly. They'll draw a squiggle and they'll just be like, oh, I don't know, I don't care. They'll put a random squiggle over here, which always cracks me up. Don't do that. Just calmly connect your dots. I'd recommend do the positive side first, then do the negative side, and try to make it as smooth as possible. That's a good looking cube root function. Since I can plug in any x that I want, and since I can plug in any y that I want, look, I'm going right as far as I want, I'm going left as far as I want. This actually is going to go down forever and up forever. The point is, for my domain and range, I have a domain of all real numbers. I also have a range of all real numbers. And the reason is because there are no restrictions on cube roots. I can plug in anything, therefore I can get out anything. So domain and range, all real numbers. For every cube function, no matter how much you translate it, it's going to be this. But let's actually translate it. So here we go. First of all, I'll draw my parent function. 0, 0, 1, 1, over 8 up 2. Same thing on this side. I'll connect the dots. Remember that we need to take care of our reflections and stretches first. In this case, I think I used green for the reflection one. In this case, I only have a reflection, which means that all of the y values are going to be negative. So over 0, 0 is still 0. But over 1, instead of up 1, go down 1. Instead of down 1, go up 1. Over here, instead of down 2, up 2. Over here, instead of up 2, down 2. It is a reflection. Notice that my graph is exactly flipped, and it almost looks like DNA. Next, I need to take care of my shifts. Don't forget that one shift lies to you while the other tells the truth. This one is the liar. It is moving left. This one is the truth teller. It's moving, oops, because of the negative, it's moving down. I just spit on my laptop, but you can't see that because it is physical spit, not virtual spit. I just wiped it off. That's why the screen moved. Fun stuff. So every one of these green points, I'm going to move left 1, down 6. So let's start with this guy. Left 1, down 1, 2, 3, 4, 5, 6. This guy, left 1, down 1, 2, 3, 4, 5, 6. Next one, left 1, down 6. Left 1, down 6. This one, left 1, down 1, 2, 3, 4, 5, 6. Now, it can be easy. Here's where students are like, oh, I don't know. Whoa. Just connect the dots. Remember, this was kind of the center point, like this point turned into this. So just start from the center point. Don't do anything too crazy. There is my final equation after translations. Let's do our domain and range. But remember, the domain, it's all real numbers because I can plug anything into a cube root function. I can plug in negatives or positives. Range, therefore, is also all real numbers. And remember, if you're looking at the graph, it goes right to infinity. It goes left to infinity. Also, it happens to go up and down to infinity. So here we have it. Summary, for square root functions, domain and range are restricted. Look at the vertex equivalent. So kind of that stopping point, sort of like the vertex in a way. It's where the function's about to turn around, but then it just stops. Look at that stopping point to find where the function begins. However, for cube root functions, domain and range will always be the all real numbers. All right, that's it. If you don't remember your reflections, go back and watch an old video because we have done the reflections, translations before. It was back in absolute values, so maybe search for absolute values on the channel. Anyway, cheers. Enjoy the rest of your day.